We are on the sections 2.7 and 2.9. We are going to talk about optimization and applied optimization. Okay, so what we are going to talk about is like, maximize your profit and minimize your cost, right? So you optimize your operations. So how we are going to use the things we have learned, the first derivative and second derivative, to apply to those concepts, okay? Before we do that, we need to talk about a bit of other things. It's called absolute extreme values, okay? A few small concepts before we go into optimization. And the absolute extreme values means this way, okay? It means it is what? Those values, okay, are the largest, largest or smallest values of the function on its domain. So what does domain mean? Domain means what? All possible x values. That means the domain you are working on, it means, okay, from year 5 to year 10, okay? Or you are working from year 0 to year 10. That's your x value, that's your domain, okay? You don't work, say, 100 years from now on, right? So that's the domain we are working on. And let's see, what's the largest values, what's the smallest values, okay, of the function. Let's see, what do we mean by that? So let's take a look at the pictures first, okay? Situation like this. If first one, if the market fluctuate like this, right? So you have this point and this point. And this one, those points, this one we call them what? A relative maxima or minima. Sometimes we call them a local maxima or minima. Just around that time, it happens this way. But if you say, okay, from beginning of time to the end of time, we are talking about this one may not be the absolute minima, right? This is only relative minima. Concept like this. Then if you have a graph like this, then what do we have? We have a minima, right? But we have no maximum, right? If we have situation like this, then we have a maximum, then we have no minimum, right? And if you have like this, then what do we have? We have no maximum, we have no minimum, right? So those are our models. And in the problems, and we use what? Functions to represent models, right? So next one, we are going to see something called optimizing continuous function on closed intervals. Closed intervals means, okay, I'm only going to deal with from year 5 to year 10, not infinite. Okay, that's what we are talking about. So it says to find an absolute maximum or an absolute minimum values for a continuous function on a closed interval a to b. That means, okay, I'm going to do year, say, 5 to year 10. Okay, things like this. Then your a would be 5, b would be 10, right? So if I'm only concerned in this between this time frame, okay, what we are going to do? We are going to find something we talked about before. We are going to find the critical numbers, okay, and to decide critical numbers means what? Those turning points, right? We talked about before, critical numbers are what? Are those x's during those years, right, that are critical, right? Like those and those. And also we talk about, okay, just a review, CPs is what? Are those points, it's different from X's. Critical numbers are the years make critical for the business, right? Critical points are those X and Y's are those points, all of the pairs, they are critical. Let's see what do we mean by that later again, okay? And we also use these terms, EPs, we are talking about is endpoints. So what does endpoints mean? What do the endpoints mean? They are what? We are talking about between 5 and 10. Endpoints would be what? 5 and 10. Okay? So, let's take a look. If, let's see some examples. So, find the extreme, absolute extreme values of this function. On this time frame, say year 3 to year 0 to year 3, right? So if we want to find the absolute extreme values, absolute means what? Including everything in between, okay? Not only local one. So then first, what do? You do the graph, okay? So you find out if you do the graph on your calculator, then you will find out something will be like this. Okay? So then how we are going to find out those points, right? When did it happen? Which year it happened? When you have local maximum, right? Then it stopped here. So we are talking about between 0 and year 3. So what do? Then we know when at this point you must have what? F prime is what? 0. Okay? because your tangent line, the rate of change, it didn't change up or down, right? At this point, is 0. And at the other point, it's changing up, changing down, right? Okay, so what do? We find the f prime of x first. So you do the derivative, which is this one, right? Then you make this 0. Then what's your x? You solve it. So you take a 3x out, would be x minus what? 6, right? What happened? Oh, I forgot my 15, right? So let's find out. So we take the 3 out, would be x squared minus 6x plus 5. Then you factor it, becomes what? Minus 5 and minus 1, right? So we say f prime is 0, means what? They are critical numbers. F prime at this time, just like those, right? Can be what? They didn't change the rate of change at those points. F prime is 0, right? But it can be what? Maximum or minimum at the time, right? So what do we have? So our critical numbers will be what? X is 5, X is 1. So during the year of 5 or year of 1, you have a critical situation. But we are dealing with what? We are dealing with between years 0 and 3. So we don't have to worry about year 5, right? Because that is what? Out the range of we are talking about, right? So our critical numbers would be critical numbers is at year when? This one, right? So our critical numbers would be at x is 1. Is that right? Then the question was find the absolute extreme values. So that means for the whole time, what's the highest point? What is the lowest point? Right? So at this time, the highest point would be what? F1 would be 7. 7 is your highest point. But at the same time, it might be a situation like this way, right? So this is your highest point, but if beginning of time is higher than this, then this one will be only a local, not the absolute for the whole time. So we want to check the endpoints, see the result, okay? So you try it. So you try at the beginning is what? Endpoint is 0 and 3, right? So you try F0, you plug in, it's 0, right? Then you try what? F3 is what? You plug in and it's -9. Okay? So you compare those points and to decide what is absolute. So we say on your earlier in the middle, it says for the absolute maxima or minima, then you find all those local points. Then at the same time, you compare the endpoints, right? See what's the highest, what is the lowest. So your answer would be what? Absolute maximum. Okay, this one. would be what? 7 at year is 1. Then this is the lowest one, so your absolute minimum, it would be what? -9 at what? Year 3. That's how you look at the graph to decide, the whole time, what's your highest profit, what's your lowest profit, this way. Okay, so give you a little bit idea how to use F prime to decide your local maxima, local minimum, and also the absolute minimum and absolute maximum. Okay? That's the first F prime. So we say we use F prime to decide, right? If F prime at this time, okay, at that time F prime, if it's 0, it means what? F has what? A local maximum or local minimum, right? Then we use further derivative, F prime prime. So we use what? F prime prime at the time of C. Okay, at this year, we say if it's bigger than 0, it means what? F has a what? Minima or maxima. Okay, on your page 51, we talk about it. If it's opposite, so F prime prime, it's bigger than C, bigger than 0, it means what? Concave up. If it's concave up, then it has what? A minima at the time at that year C. Okay, and if F prime prime at year C is 0, less than 0, it means what? Concave down. Then F has a what? Maximum at year C, right? On your answer key paper, then on the page 53, there are some typos, so you can fix those as well. Okay? And let's look some examples. On your page 54 on the top, optimizing the value of a timber forest. It says the value of timber forest after T years. So T is your years, okay? And its value like this, value after so many years, it will be 96 square root of T minus 6T, okay? T is bigger than 0. So for a timber forest, you say how much it worth. If you work for a logging company, right? You want to know how much it worth for the what? $1,000 value. Okay, that's the value it says by thousands. So we want to find out when the timber forest value is maximized. It worth so much to maximize. So what do? So first, you will use calculator, right? Or you use website to do the graph. At the 0, that's 0. You just plant your trees, then you find out, it looks like this. Then you want to find out when, which year. So T is your years, then that's your value. You want to find out when that will worth the most value at this time, then how much it will work, right? So what do? According to what we have learned is what? When you have prime, take a prime when it's 0, it has the local relative maximum or minimum, okay? But you don't know it's minimum or maximum, so you'll need to use f prime prime to check, right? So what do? First, you take a prime first, so you change this to what? 96 to t to the half power, right? So that would be 96, then you drop one level, that would be negative half minus 6t. So that would be 48t negative half minus 6t, right? Then we need to use the second derivative concept to decide we have maximum or minimum. So you take a second derivative, that will be what? Negative 24, drop one level, 3/2 minus 6. Let me see. 6t, take a derivative, I shouldn't have t anymore. So I take a derivative, I should have this, right? Now we need to find the prime. Becomes 0. So you take this one, it's 0 equals what? 48t negative half minus 6, right? Make a 0, that means what? 6 equals 48t and half, right? Then you divide by 48. So what do we have? 1/8 equals t and negative half. What does t negative half mean? Reciprocal. So 1/t and half, which is what? Square root t, right? So that's why at the beginning, at the first week, we review all the what? Polynomials and quadratic equations and exponential equations and log to help us to deal with situations, right? So that will be what? Your 8 equals square root of t, right? Then you take a square, so your t is what? 64. So it's telling you at year 64, you might have maximum or minimum value, right? We don't know which one is. Then we need to use the second derivative to check, to see which one actually is. So you plug in at year 64 to this one, negative 4t negative 3/2, right? It means what? Negative 24 divided by what? Reciprocal, right? To the third and 2 square, right? Then your t is what? T is 64, so it's 64 to the third power and negative 24, right? You take square, actually it's a to the third power and 24. So you use a second derivative to check its local minimum or local maximum. So this number is what? Bigger than 0 or smaller than 0? Smaller than 0. So what does it tell you? So it is what? At this time, Vt is a maximum value and t equals 64. So it's telling you what? The value of the forest is maximized after what? 64 years, right? At what kind of value? if you need to find the value for the original, you need to plug in. Okay, so you plug in V64. You plug in that 96 and 64 minus 6 times 64. So according to this model, you will have what? 384. So at the year 64, you will have what? Maximum value at, so it's saying, what it's saying is, right, at year 64, and it has what? The maximum value at what? By thousands, right? $384,000. Is that what it's saying? So that's how we will use what? The f prime and the f prime prime to check, to find out what's the maximum value at what time we will have those, right? So that's what we are talking about, optimization for those. Now let's talk about profit, okay? And see how we are going to use f prime, s prime prime to maximize our profit and minimize our cost, right? So let's talk about how we usually count the cost, right? Then how do we do the revenue? Then how do we do the profit, right? You know, profit would be what? Your revenue minus your cost, right? Then how do you figure out your revenue? You will do what? You check out your sale price, right? And times what? Your quantity you sold, right? Then how much it will cost you? You will do what? Your unit cost, say each one is $20. Then you sold so much quantity sold, then that will be your actual cost for the material. Then see, you find your revenue, you find your profit this way, right? And let's just do that. And we usually use what? Use X as what? Quantity. Okay, so we solve for X, then we find out how many, units being sold, right? So we do this way. Your cost is how many of them you sold, then that will be how much it will cost you. If each one is $20, which is 20 times 50 sold, that will be your cost, right? So you will do what? Unit cost times what? Quantity sold, right? Then your revenue will be what? Your selling price. Your price you sold, right? It may fluctuate because you want to figure out, should I sell higher or should I sell, lower to maximize? Because when you sell higher, you might sell, smaller, lower quantities. So your price, selling price may fluctuate. but the unit cost problem is fixed. So what kind of profit you will have? The profit we write it as such, right? Your revenue minus your cost. Is that right? Okay. So we also did some average cost, marginal average cost, and those type of things. Then we figure out, we review those later. And let's see next example. Okay, so see how we will use the basic concepts of your business world to do the problems on your page 55. Okay, so take a look at your page 55 and example 1. Okay, it says maximizing a company's profit. It cost the American automobile company $8,000 to produce one car, right? So that would be what? Your unit cost to produce them. And the fixed cost would be what? Rent and other expenses that do not depend on the amount of production are what? $20,000. That's the overhead, right? Per week. Okay? The company's price function is this way. It gives you, say, my price is according to my quantity, 22,000 minus 70x. What is saying? If x is 0, my price is what? $22,000. It means my original price I set up is what? $22,000, right? It says P is the price at which exactly X car would be sold. If X is 0, then that would be $22,000. If you sell one car minus 70, it means what? $70 discount. That's what it's saying, right? If you sell 2 cars, I'm going to what? Give $140 discount for each car. So the more you sell, then the cheaper the car prices will be. Right? That's what the function is telling you. The price is according to quantity is sold. Okay? So if you set up this kind of thinking, then you thought, okay, how much discount I can afford to give, then actually maximize my profit. Okay? So, look at the questions. First one, how many cars should be produced each week to maximize profit? For what price should they be sold? And what is company's maximum profit? So the bottom line is what? You want to maximize your profit. So hopefully you sell more cars to a point you make more profit with discounts given, right? So before we do that, we have to set up for all those your function, right? So what's your cost? Each one is what? $8,000. right? And times the car, how many you make. We are talking about per week, right? But you have to add what? $20,000 for your overhead, right? That's your cost. How about your revenue? Revenue will be this, your price times the quantity sold, right? So revenue equals what? Price times quantity sold, quantity, right? So that will be what? P times your X, quantity, right? X is your quantity. So then your price is what? According to your quantity sold, so actually is what? That will be 2 plug in 0 minus 70x times x. Is that right? Okay, so that would be, okay, we'll just write it out. Right? Then let's do the profit. How's the profit? Profit would be what? This one, right? Profit equals your revenue minus your cost. So revenue is this minus your cost. That would be this one minus here, right? So that would be 70x squared, and this one minus that one would be 22,000. Let's just write it out, okay, here, okay? So let's just write it out so you can see. 12,2,0,0,x minus 70x squared minus cost. That would be what? 8,000x plus 20,000, right? So that would be negative 7x squared minus 14,000x minus what? 20,000. Is that right? Okay, so first you have to write down all your equations just according to your thinking, right? Your thinking is what? You are going to give a discount, $70 for each car, and with original thinking of $22,000 per car, right? Then you wonder, how many I can sell, then which can maximize my profit. Okay, so X is what? X is your quantity. How many cars you plan to sell, all right? So you produce so much, you give so much discount, right? So the first one, it says, how can you maximize the profit? How many cars should be produced to maximize the profit, right? So that's the maximize the profit. We use our derivatives concepts to do that. So you do what? P of x, right? You take a prime, right? So you take a prime on this, that would be what? Move over, 140, drop one level, x, right? Then, oops, that should be plus. Okay, then plus 14000, right? Then we find out the prime equals 0, so equals 0. Then you solve your x. So your x is what? 100. You find out if you prepared 100 cars with its discount, you might have maximum profit. Or you might have what? Minimum. So you need to check, okay? So you need to check if it's a minimum or maximum, right? By doing what? P prime prime. okay, with P prime prime. So let's do that. And take a P prime prime x would be what? 0, that would be 140, right? Less than 0. If less than 0, it means what? It means you will have maximum profit, right? When you have X is 100 cars are produced each week. That's what it's saying, right? So you say you can plant 100 cars each week with what? 100 cars, each car you will give what? 70 times 100, $7,000 discount, right? That's a pretty good price. So second question, for what price should they be sold? So the price will be what? The price would be what? P of 100. So that would be 22,000 minus 70 times 100. That would be what? 1,500. So you are thinking, each car you will sell as what? $15,000 instead of $22,000, right? But you can sell 100 cars, actually give you more profit. Okay, then let's see what kind of profit you will have. So you plug in. So to your equation is here, negative 700 to the square plus 14,000 to the 100 minus 20,000. So that would be 680,000. So you can make 680,000 per week. Say if your sale price is 22,000 per car, you sell 0 car, you make no profit, right? Actually, you will lose what? $20,000 per week, right? If you sell so high, then you start to give discounts, then you realize you can make more, right? So let's write it in words. So what's the conclusion? Okay, so we say, okay, with this kind of thinking, the company should try to do what? Should make 100 cars, right, per week, right? And sell how many? If they make 100 cars, they can give what? $7,000 for each car discount, right? And sell them for how much? Actually, $15,000 each to maximize the profit. Actually, to how much? Profit of what? $680,000 per week, right? Then you can plug in, okay, if you just sell 10 cars, then you only give 700 discounts, but you sell only 10 cars, much less, so your revenue is less, your profit is less, right? That's how we are using what? F prime and F prime prime to adjust your price along with quantities. Got an idea? Okay, let's see how we are going to maximize the profit Okay, so we know cost is that way. It's a unit cost times the quantity you make, right? Then revenue will be the sales price times what? Quantity X sold, right? How many you sell, then how much revenue you will make. The profit will be what? Revenue minus cost. So let's look the example on the page 56. Maximizing profit. Let's see how we can handle this situation. It says a store can sell 20 bicycles per week at a price of $400 each. The manager estimates that for each $10 price reduction, she can sell 2 more bicycles per week. The bicycles cost the store $200 each to buy in. Okay? Then we want to find out, okay, if you sell $10 cheap for each bicycle, how much you can make, then how much profit you can get. So if you are the bicycle shop manager, right? You have this situation. What do you think you will handle it? Right? So it says, okay, so far it can sell how many bicycles per week? 20 bicycles per week, right? Then at how much? $400 each, right? Then for $10 price reduction, then you can sell 2 more. So if $10 production, then it will be sell each one is what? $390. Then you can sell 22 bike, right? If you sell $380 each, you will have what? Sell 24 bikes. Okay, so you wonder, how much deductions you should offer, right? Then you can sell more bicycles. Then will you make more profit or not? That was the question, right? So there are 2 ways to resolve these issues. Then let's do first method, okay? Let's do method 1. Okay, and say how many reductions and you will make, then how much profit you actually get, right? So let's do the analysis first. That will help you to reason things, okay? So we say, okay, I'm going to sell how many bicycles? 2 bicycles, okay, per week. 20 bicycles per week. Then the price would be how much? $400 each, right? And your cost, unit cost to buy in each one is what? $200, right? Let's figure out the profit. So mainly we are interested is what? The profit, right? So if you buy in 400, sell with 200, so you make what? $200 profit for each bike you sell, right? Then it sells what? 20 of them. Then that will be what? You will make $4,000, right? So you will sell 2 more bicycles, right? If you have what? $10 drop, right? Your unit cost is still same, right? How much you can make? Okay, if you drop $10, so that will be what? You sell $390 minus 200, right? For the cost. Then how many bicycles you can sell? You will sell what? 22, two more, right? You make 4810, right? And you, okay, you do another $10 drop, then that will be what? 380 minus what? 200. Then you will sell two more bicycles, so that will be what? 4320, right? So if we continue to do that all the way, you drop $10, $10, $10. If you drop to 20, only make it $10 for each bicycle. How many you can, right? You drop how much? From 400 drop to 210, you dropped how much? $190 drop, right? For this one, $190 drop means 19 times 2, you will sell what? 38 more bicycles, because for each $10, you sell two more bicycles, then $190, right? For $10 drop, 19 times, so you will sell what? 2 times 19, 38 more bicycles, right? Plus original 20 bicycle we're talking about, so you will sell what? 58 bicycles. So you continue that, then you only make $10 each. Then you make what? Profit only $580, right? So say if you sell $200, you earn nothing, but you will have demand, say 60 bicycles, right? Because 60 people may interested to get a bicycle. So you make a $0, right? It doesn't make sense. However, we just take a look at our analysis first. That means, you see, your profit gets higher, 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 right? To a point, it start to drop. Okay? So we want to find a point somewhere in here, actually make the highest profit for you. Okay, if you look at the numbers, right? So idea is, you don't know how much, discount you wanted to offer, right? Then quantity sold will depend on how much discount you will offer. So for this situation, we have this one, okay? So situation is sell price is what? Undecided, right? At the same time, it will impact the quantity sold, right? Becomes what? Unknown. You have to decide your price before you know how many bicycles you can sell, right? So idea is, once the price is decided, once you decide the price, then you can estimate, right? Can estimate, sort it out how many would be sold. Right? So you have two numbers depending on each other. Then how we are going to resolve it? Okay. So then let's see. We just use our basic business concepts, right? Cost is how much you acquire your material. Revenue is how much you sold. Profit is how much you make in between. So if you can set up your equations, then see if we can use our skills we learned, okay, with advanced thinking like derivative and the second derivative. See if we can get some idea, okay? So we can set up is this way. Okay, it's different. It's depend on how many reduction we are going to use. So this method is this way, right? So it's different as what? How many quantities sold? It's different. Because we want to figure out how many $10 drop I'm going to give. So then I know how many, I will know what's the price. Then I will know how many bicycles I might be able to sell. Then I will know my profit, right? So I'm going to set up this way. This is one way of doing it, okay? So you say X equals what? The number of $10 dropped. Okay. One time drop $10, two times drop $20, things like that, right? Okay. So if I know how many $10 discount I'm going to give, then I would know the rest of them, right? From this analysis you can see. Okay? Then if so, then what's the sale price? So the sale price, right? So your sale price would be what? Your sale price is this, right? P, your sale price would be what? Depending on how many $10 you drop, right? One $10 will be $10 discount, two $10 will be what? $20 discount. So it was $400 minus what? $10 discount times how many of discounts you are going to offer, right? So your price is according to that. Then that's your sales price. Then how about quantity? How many bicycles you are going to sell? It says it was 20 bicycle at the beginning, right? 20 bicycle at the beginning. But each discount you make, you can gain 2 of them, right? So it was 20, then each discount you can sell 2 more. So that would be total bicycles you will sell. That would be your this thing, right? Would that be that thing? Right? Then total this price, will that be those things? Does that make sense so far? Right? So you can set up this way. Then once you set up this way, we are going to use those concepts. All right, find the profit function like that. So let's do the cost. Cost is what? Unit cost times what? Quantity, right? Quantity. So unit cost times quantity sold. So it will be what? Unit cost is what? $200. Quantity sold is what? Times your Q. Then Q is this guy, right? Now Q is not X, not like that. Quantity is depend on your number of discount, right? Number $10 dropped. So that will be your P and Q. Okay, so for cost, it would be $200 times Q. That would be 200 times what? 20 plus 2x, right? Then for your revenue would be what? Your sale price times what? Your quantity sold, right? So sales price changed, right? So that's your P. So it will be 400 minus 10x times quantity sold. That's your quantity. Is that right? So that would be what? Quantity would be, where is the quantity here? 20 plus 2x, right? Then your profit would be what? Your revenue minus your cost, right? Then we will multiply those. So you use 400 minus 10x times 20 plus 2x, right? Minus this one, right? Minus your cost. Is that right? Then we just simplify. It's what? 4,000 plus 200x minus 20x squared. Okay. Then that's your profit function. Represent the where? That's this column. Right? Revenue would be the first number times the quantity, right? First number times quantity. The cost would be this 200 times quantity, 200 times quantity. If we use the function to demonstrate our idea, right? Then if we take a derivative of x, we say if we want to find the maximize the value, you take a derivative. First derivative. If it's equal to 0, you have maximum or minimum. Then you use a p prime second derivative to verify it, whether or not it's a maximum or minimum. Okay, so you take a derivative of this. That would be what? 200 minus 20 times 2. That would be 40. Right? If we set this to 0, then you will make what? X equals what? 5. Okay? Then we check. This one is the minimum or maximum. So P prime X is what? Negative 40. If it's less than 0, that means what? It's telling you, okay, at this point, so when X is 5, okay, it will maximize the profit. Okay, so let's see. And 5, what does 5 mean? It's the number of $10 drop. So if you drop 5 of those $10, that means what? You drop here, the price would be what? 400 minus what? 5 of the discount. So that would be what? $350 each. That's the price you are going to sell. Then for the quantity, how many you can sell? For the bicycle, 20 plus 5 times 2. 2 per $10 drop. For 5 drops, that's what? 10 or more bicycles. So you can sell what? 30 bicycles. Is that right? Okay, so the second question was find the price of the bicycle and the quantity that maximize the profit. So that would be the price, sell, and 30 bicycles, right? You can maximize the profit. Instead, you write down everything, say 1 drop, 2 drop, 3 drop, 4 drop, 5 drop, all the way to what? 20 drops, right? 20 drops, you drop what? $200, then become $400, drop to $200, become $200. So you can write what? 20 of them. Then you can find out the middle one. When it's 5, then you can maximize your profit. Okay? With $50 discount, you sell each bicycle with $350, then you can sell 30 bikes, right? Or you can just do the table list 20 times, takes you forever. Or we can use the new skills we found and with derivative and second derivative to verify, then we find out 5 is the magic number. Okay? Then next one, it says, okay, find the maximum profit. So that's your profit function, right? If you plug in there, so P of 5. If you plug in here, right? And that would be what? $4,500. That's per week we are talking about. When you drop 1, you make $4,000 per week. 2, 3, 4, 5. When you drop $50, you can make what? $4,500 per week. Okay? So that's one way to think about it. That's more straightforward way to think about it, because it says, oh, I give $10 discount, right? Then how much discount I'm going to offer? 1 time, 2 times, 3 times, 4 times, 5 times, right? So you can just do that. So the thinking is, that was the question, how many discounts you are going to make, right? So that's one way. And some people find that this way is better, and maybe not. Okay? Then your homework, use this method. You can compare which one is more connected for you. Okay? So this one is going to use the demand function on your page 34. All right, let's follow up the thinking on page 34. Okay, so demand function is saying what? If you can sell cheaper, you might have more demand, right? Or if the demand is higher, you can sell it cheaper, right? So it's talking about demand function. You can look at this way, okay? Price according to demand, right? Then it's saying what? $10 drop, you will have what? 2 more bicycle sold, right? That's what it's saying in demand function. Then if you look at that, so the graph will look like this, okay? When you sell demand is 20, right? This is X is your quantity. They are using X as quantity. So when you have 20 in demand, right? What's the price? Price will be what? $400. Is that right? If it's a 22, the price will be what? $390, right? If it's 24, the price will be what? $380. Is that so? So your demand function looks like this. The price is according to the demand quantity. Okay, like here we say once we decide the price, then quantity will be determined. Here is saying, okay, I decide how many quantity I expect to sell, then I'm going to give that kind of price. The price will be that way. Okay, so then you can take a look. Then we use your algebra skill, right? We say y equals what? mx plus b. We want to find this function, demand function. So this one is demand function, right? Price is according to the demand quantity. Okay, so that's the equation. Then how we are going to decide what's your M, what's your B? You do this way to find out, because we do have data from here, right? Then what is your slope? Slope is what? Rise over run, right? Rise over run. So from this point to this point, right? Then the difference is what? Is what? Rise over run. Is what? The difference on y divided by difference on x, right? So difference from what? 390 to 400. So it's 390 to 400 is from what? 22 to 20, right? That's your y, that's your x. Y over x. So that would be what? -5. So your function will be y equals -5x plus b. Then you don't know the b. You have to find it. How? That's your x, that's your y, right? Then you can just plug in. So what do? Plug in x and y. So to find your b. So x is 20, y is 400. So how about 20 and 400? You do that. So you will have 400 here equals -5 times 20 plus b. If you do that way, then your b is what? 100 move over, so b would be 500. If you do that, and what do you have? Y equals mx plus b. Y equals m is -5x, b is what? 500. So this your demand function. Okay, so use demand function to do this. That's what we are doing. Instead of using how many reduction discounts you are given to solve problems. Okay, if you do that, then we skip the question. Skip. Okay, we skip A, and we are using what? Using X as quantity. Not as the question I was asking you if X stands for the number 10, price reduction. We are using X as quantity. Okay? Then let's do this. we still use the business concepts. They are the same, right? So CX would be what? Cost. We use X as what? A quantity. Now, so C of X would be what? Unit sale, $200 times quantity sold. And RX would be what? Sale price. Where is the sale price? That's a sale price, right? That's the price times the quantity. What's your sale price? Look at that. X is your quantity sold. Then Y is what? Your price. P of X, right? Because the price is what? According to your quantity X. So this P is what? Y. P is what? P is your Y, right? So Y is your P, which is according to your X. That's what happened. Okay? So then your revenue would be price times quantity. Your price is this function, demand function, times quantity sold. Price is according to quantity by demand function. Okay? So then your profit would be what? Revenue minus cost equals what? Then this minus that. Okay, you multiply them, 5x squared, 500x minus 200, so you have 300x. Then your profit function is a different function, but the x has different meaning comparing that one, right? So if we do the same thing, the rest of the skills are the same. So we take a p prime x would be what? Negative 10x plus 300, right? If this is 0, what's your x? X is 30. What is x? Quantity sold. That means what? When you sell X 30 bikes, you will maximize or minimize your profit. So if you do P prime prime X is negative 10 less than 0, that means what? You will maximize the profit when you sell 30 bikes because X is quantity, right? If you sell 30 bikes, what kind of price would be? Demand function Y is your price, right? Price. So Y is what? Negative 5 times 30 plus 500 would be what? 350 is $350 per bike. Then let's do the what? Main thing is we want to find the what? The profit. Then what's the profit? Profit will be according to this one, right? When you sell 30 bikes, so 30 you plug in there, then that will be what? You plug in there, that would be negative 5 times 30 to the square plus 300 times what? 30. You will end up $4,500 for a week. You still get the same answers. Okay, think about it and try to connect it. That's how it works, right? It only tells you, okay, $10 discount. Then how many $10 discounts we are going to provide? Then how many bikes we are going to sell? Both of them you have no idea. You only know you come in with $200 each bike. Then you know for each $10 discount, you can sell 2 more bikes. Then you can use your understanding, business thinking. Then this one you use what? Demand functions to do that. The homework use this way. Then see whichever is more, reasonable to you. You can use either way. Okay, let's look at the next one on your page 57. It's a similar concept, okay? So, it says, an orange grower finds that if he plants 80 orange trees per acre, each tree will yield 60 bushels of oranges. He estimates that for each additional tree that he plants per acre, the yield of each tree will decrease 2 bushels. Okay? Because the more trees you plant, then you will yield less orange for each tree. Okay? Then he said how many trees should be planted per acre to maximize the harvest. Okay, so we will do the similar ways, right? Instead of how many reductions, we are going to say by how many additional trees we are going to plant, all right? By how many additional trees we are going to plant. All right, so we will see, instead we do all those, then we just do the things according to the questions. So we will say, okay, I'm going to grow how many trees, okay, per acre. Then each one will produce how many bushels per tree, right? Then we figure out what's the harvest to figure out that. Then we set up our X, then we figure out our what? Yield this way. Okay? We see how we are going to do that. So we do the analysis first, then you will have some kind of idea. All right? So how many trees we wanted to, plant it per acre? Undecided. Right? Then we produce how many bushes per tree. You will be unknown at this time, depending on how many you decide to grow, right? So the harvest is what? It says if you grow, it was what? Started from 80, right? Started from 80 trees. If you grow 80 trees, then you will have 60 bushels of oranges. So if you add X trees, right? Then you will have what? You will, if you minus 1 tree, how many? Wait, okay, so 80s are trees. Those are trees. Those are bushels, right? So if you what? Originally you started from 80 trees per acre, right? If you increase 1 tree, so this one you will yield what? 60 bushels, right? If you increase 1 tree, you will drop 2 bushels. If you increase another one, you will what? Drop another one, right? So then if you say drop 1 tree, say you drop 1 tree, you should what? Increase 2 bushels per tree, right? If you drop 2 more, then you will what? Increase, so it will be minus 1, so then it will be plus 1, right? It will be minus 2, total minus 4. It means so minus 4, then we'll just say plus 2, minus 2, that will be plus 4, right? If we do the analysis, that would be this way. Okay, so the harvest, so if you have add 1 more, you will what? Drop 2 bushels. Is that right? Okay? Are you with me so far? Then we see how many actually the harvest will be, means what? How many oranges you will have. So for this case, you will have what? 80 trees plus 60 bushels. So you should have what? 4,800 bushels of orange, right? If you add 1 more tree, 81, you will have less bushels of orange. You will have what? 4698, right? Then, oops, is that decreasing or increasing? Oh, decreasing. If you plus 2, you do 82 trees, then you have 56 bushels of orange. It's 4592. Oops, it's a decreasing. It doesn't sound good. How about another way around? If you plant less 1 tree, right? Then you will have 2 more bushels, so you will have what? 4898. That sounds better. So if you 2 more, less 2 trees, 78 trees, then you have 2 more bushels, so that would be what? 4992. That sounds better. So what does this data tells you? It tells you plant less trees than 80 trees per acre. That's what it's saying, right? Okay, so you have an idea your X supposed to be what? How many additional trees you will have. So your setup should be what? X should be negative to give you more result, right? So your X would be what? The number of trees planted, right? So increased or changed. That's the idea. According to this, actually your X wanted to be what? Negative, right? So what do we have? You will have what? How many trees per acre now? How many trees per acre? So the trees per acre become what? Becomes 80 plus X, right? If X is negative, then minus number. Then how many bushels per trees? Bushels per tree, that would be what? 60 minus 2x. Is that right? If we use this method, let's see how we are going to write down our yield, right? So the total yield will be what? Your yield supposed to be, how do we get those total yield? So it will be what? Number trees per acre times what? How many bushels per tree? Is that right? So your yx would be what? This one is this 80 plus x times what? 60 minus 2x. Is that right? Okay, then let's see. We multiply them out, we get our function, right? Then what do? We use the derivative. Derivative of x, that would be what? Negative 100 minus 4x, right? Then derivative, second derivative will be negative 4. So if we do that, if we make this 0, x will be what? Negative 25. Then y prime prime, so then it's less than 0. That means what? Y negative 25 is less than 0, right? So it's what? Opposite. Less than 0 is concave down, then you have a max, right? So x equals negative 25. We will what? We will maximize the harvest. Is that right? Got idea, right? So let's see, the question was what? How many trees should be planted per acre, right? And to find out, we can maximize the harvest, right? So then we realize if we plant 25, where is your x? 25 trees less, you will maximize the harvest. Okay? So the conclusion you can make is this. If you plant 55 trees per acre, right? That will yield the total among how many? Of how many bushels? So how do you find your bushels? So for 80, so 80 minus 25, so you will plant how many trees? 55 trees per acre, right? Then yield will be what? 55 per trees, right? Then each tree will produce how many bushels? Because each tree you reduce will be 2 bushels more, so you will produce what? 50 more per tree. It will start from 60, right? Then you plug in negative 25 here, so you will be what? 110 bushels per tree, right? So you will have how many? 5650 bushels for the harvest, right? So you will yield a total of what? 5650 bushels, right? To maximize the harvest. Right? Okay, and let's see how the demand function will handle this situation. Okay, so we're not talking about price now, we are talking about what? Okay, it will be this way. It will be what? We are talking about the yield is what? Is according to the quantity, right? What does that mean? It means if you increase one tree increased, you will have what? 2 bushels dropped. Right? So what he's saying is, instead we say that because quantity yield is 2 bushels. Okay, total how many bushels? So 2 bushels dropped if 1 tree increased. Okay, because bushels is your yield, and quantity we are talking about is how many trees per acre, right? So your demand function will look like this way instead. Okay, it will look like this one. We started from 80. Then when we have 80, we have what? 60 bushels, right? Then if you increase 1 tree, 81, then how many bushels we have? We will have 58, right? Because you drop 2 bushels. So if you have 79, so you will have what? 62 bushels of oranges. So it looks like your demand function. So the quantity is the tree, how many trees per acre you planted. Then the yield is your Y. Y actually is what? Is the how many bushels per tree, right? Then how we are going to write the demand function. So demand function is written this way, y equals mx plus b, right? If you write this graph, linear graph, then you can derive the m and b. What's m? M is what? Difference on y. So it's what? 60 minus 58 divided by what? It should be 58 minus 60, right? 58, where is it? This is a 60, right? 58 minus 60 over 81 minus 80. So it's what? -2. The difference, the slope is what? Decreased by 2. It's what it's telling you 2 bushels drop. So it's decreased by 2. So then y equals what? We want to find the b. So y is negative 2x plus b. Then how do we find the b? We find the point, right? 80 match with 60. That's x, that's y. So you plug in x and y is what? 80 and 60 to find your b. So it's y is 60, right? Equals negative 2x is 80 plus b. So what's your b? 160, 220. Is that right? So your demand function is what? Y equals negative 2x plus 220. Right? Then y is what? Your bushels. So what we have is say bushels, B-U-S-H, right? It's depend on your quantity. So that's your yield. How many bushels total your harvest? Then according to how many trees you have. So X is the tree. How many trees per acre? So that's your demand function. Okay? The yield, the demand is the result of quantity. Right? So first you set up this way. You have to find your demand function. All right. So that's your first step. Then second step, you will find out. So you'll try to find the yield function, right? So the total yield, right, will be what? Equals number of trees per acre times what? That will be the same here, right? How many bushels per tree, right? So our yield is according to the quantity, how many trees we planted, okay? So how many trees per acre? How many trees per acre is your quantity, X? How many bushels per trees is this guy, right? B of X. So you multiply them will be X times negative 2X plus 200. Okay? Then after this is easier, don't you think? We just take a derivative. Okay? So this is negative 2x squared plus 200x. So if we take a derivative of x, that would be negative 4x, right? Plus 200. Then we find out x. If this one is equal to 0, then x is what? 55. So what does 55 mean? It's your x. Where is the x? Where is the x? That's your x, right? That's your x. So that means what? You have so many trees per acre. Okay? If you check y prime prime x is negative 4 less than 0, it means what? You maximized. That's a maximum. Right? So, same situation we will have is what? What we are saying? So, if you planting, okay, 55 trees per acre, what do you think? You will maximize the harvest, right? And you will yield how many? 5650 bushels. How do you get a 5650 bushels? That's your y. right? That's your yield. So you do what? Y55. That would be what? Here. Negative 255 squared plus 200 times 55. Then you will get what? That's yield, right? So, so how many yield that would be? So you multiply this. That would give you 5650. Got it? Or you can look at the yield this way. Yield is what? How many trees times your how many bushels, right? So you have 55 trees. How many bushels that would be? 2 times what? 55, right? Plus what? 220 plus 200. That's how many bushels of tree you will have here, right? So that would be 55 trees, and each tree will have how many bushels? 110, right? 80, where is it? 60 bushels. Then 25 trees less, that would be how many? 25 trees less. So 60 plus 50 trees, 50 bushels more, right? Because each tree will produce 2 more bushels if you do less trees. So 55 trees would be what? 25 trees less, then each one will produce 50 bushels more than original 60. That would be 110. Then for 55 trees, so you will have what? 5650 bushels for you. Are you overloaded from all those information? Okay, let's see some more examples on page 58. Says maximizing tax revenue. Economists estimate that the relationship between the tax rate T on an item and the local sales S of that item in millions of dollars is this function. So what it's saying? Find the tax rate that maximizes revenue to the government. So some economists, right, estimate the relationship between what? T and S. What is T? T is the tax rate between what? 0 and 20%, right? The sales of an item, right, in millions of dollars. So what is S? S is the total sales. So what they are saying is, government can charge the tax rate, say 10%, 20%. But the thing is, if you tax more for the sales, people may not buy it so much, then your sales revenue will drop, right? If tax rate is lower, then you might have more sales, then you might have more tax revenue. So the whole idea is what? You want to find a tax rate that maximizes the revenue for the government, right? So what we do is, let's just do some analysis, see what kind of tax revenue we can expect, okay? Let's just do a few numbers. When the rate is 0, see how much, sales will be. Then what is the revenue? Revenue per rate is what? Whatever the rate is times the sales, right? That will be the total revenue for the government in what? In millions. Okay, so if the tax rate is 0, doesn't matter how much actually sales will be. What do you think? Government will get a 0, right? So you plug in 0, sales will be what? 9 millions of dollars. So if you do 1 means what? 0.01%, right? Actually, it's 0.01%. So if you plug in, that would be what? 9 minus 20.01. That's 0.1. 20 times 0.1 is 2. That would be 7, right? Then what's the revenue? So $7 million sale, then the revenue would be what? 0.01 times 7, then 0.07 millions, right? Like 70,000 for the tax revenue for the government. So if 0.04, that would be, we plug in, would be 5 mil, then 0.9 would be 3 million, 0.16. So you have less sales, right? For how many $1 million? But your rate is high. So if you do that times 5, that would be what? 0.2. Actually, you make more money, right? For the government makes more money. If it's 3, that would be 0.9 times $3 million sale. That would be, right? Then 1, that would be, that's the rate. 1.6 times what? 1 million. It's less now. So it looks like, okay, going up, 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 and down, right? Apparently around here, then government will have more tax revenue. Okay, so then what do you think? Where is it? Must be between here somewhere, right? Let's take a look. So we wanted to find what? To maximize revenue to the government, right? So we want to find the government's what? Government's tax revenue, right? Government's tax revenue would be what? Its rate times what? Its sales, right? So what that would be? That would be T times ST. ST is this guy, right? 9 minus 20, this, right? So that would be T times 9 minus 20, T and a half, right? So that would be 9T minus 20. T is power 1 plus half power is 3/2 power, right? Then we want to find them to maximize it. So we do R prime T. That would be 9 minus 20 times 3/2 T drop one level, right? So that would be 9 minus 30t to the half power. Is that right? So if we make this becomes what? 0. Then what do we have? So this is 0. So that we have 30 square root of t equals what? 0, right? Then you minus 9. So we have what? Negative 30 square root of t equals negative 9 divided by 30, negative 30. So square root of t is what? 3 and 10, right? Then what's your t? You take a square, t would be what? 900, that would be 0.09. So what does that mean? It means when t, the rate, right? T is the rate, is 9%, then do we have a maximum or minimum? All right, so you take a derivative of this, right? That would be negative 30, then drop one level, so that would be what? Negative 15, t to the negative half, that would be negative 15 over what? Square root t. T reciprocal is this, right? So whatever t is bigger than 0, so this is a positive, so this one is less than 0. So f prime prime is second derivative is less than 0. It means what? The t will make what? The original function maximum. So you will maximize the result, right? So what's our conclusion? That's the number we found. Means what? If you use 9% tax rate, then you can maximize your revenue, right? So let's see. So it means what? Conclusion, let's write it out. A tax rate of 9%, right, will maximize the revenue for the government, right? So we are practicing what? First derivative to equal 0 to find the result. Then for the variable, that means it's critical number. It's a critical number at this point of time, 9%. You can maximize the revenue. Then checking by what? R prime prime, second derivative, it's less than 0. The result will be maximized, right? Okay, look at the next one. It says, maximizing packaging materials. A moving company wishes to design an open-top box with a square base, whose volume is exactly 32 cubic feet. Find the dimensions of the box requiring the least amount of materials. Okay, so if you are a moving company, if you manage a moving company, okay, so you are going to deliver the, say, grocery for the local, say, Safeway, right? for the local shop. Then they say, okay, this box need to, put 30 cubic feet of material in, grocery in the box. You can carry so much. And then you say, okay, if I want to design this box, then it will be efficient, right? So you use least amount of material to do it. So they say they wanted the box on the bottom is what? A square thing, okay? So say this is X, this is X, it's a square thing. Then you have open top box. Then you will have what? Things like this, right? Open top, then you have this. Right? So it's open top box. So you don't know, as long as the bottom is the square, that's what your customer wants. Then you want to think about it, and to total is what? 32 cubic feet. Oh, that's too big for the grocery company, I think. Let's see. Okay, so maybe okay. All right. Then we don't know the length, the bottom. We don't know how high it will be, but we only know the total. It can contain 32 cubic feet of size, right? But the idea is to reduce your cost, you want to use least amount of material to build a box, right? So we say we let X equals what? The length of the square, right? Side of base. It's a square thing. Then Y would be what? The height you would design. Okay? So how big it can contain, how big the size. So volume would be what? Your length, right? Times your width times the height, right? So the length is X, width is the X, height is the Y, right? So total is X squared Y. But when we take a derivative, we can only do it with one variable, right? Then we find the derivative. Now it's two variables. How we are going to do it, we figure out, okay? That's the volume. It has to be what? 32 square feet, right? And the material we will have, main thing is we're concerned about, how much material you will use, so you want to minimize the cost to make the box, right? So the material is what? Equals what? One bottom plus what? 4 sides, right? Each side will be the same. So bottom is what? X times X. 4 side will be what? 4XY, right? So we want to what? To minimize the material. That was the idea. So, but we can only use what? One variable. So this is the material. We say the area we want is what? X squared plus 4XY. But we can only use one variable. So we have to change the Y becomes some kind of X, right? But we know X squared Y total is what? 32. So what is your Y? So you can divide it by X squared. So Y is what? 32. x squared. Is that right? Okay, then we plug back in here. So plug in here to replace y with your x, right? Then so we can make it just one variable. So what do we have? So this is x squared plus 4x times, oops, that shouldn't be this, should be x squared, right? Times 32x squared. So that would be what? Square x. So that would be 4 times 32 is what? Plus 128x to the negative 1 power. Is that right? So that's your y. Right? So we try to minimize this for the material, so it will cost you less. So you do that. So take a derivative plus what? Negative 128x to the negative 2, right? Then your a prime prime would be what? 2. Is that right? 2 times plus 256 x to the negative cube. Is that right? Then we say to find the maxima or minima, then we need to set this become 0 equals 2x minus 128 x to the negative 2. Then we need to solve this. You need to know how to solve what? Your rational equation. Right? Then how do we solve this? Okay, so x is now 0 anyway, so let's just move over. 128 x squared equals 2x, right? Then we will times x squared on both sides, so we can get rid of the denominators. And let's see what we have. 128 equals 2 cubed divided by 2, 64 equals cube, right? So x is what? 4. What does 4 mean? Length of the side of base. 4 feet. Okay? So, but the 4 feet make it maximum or minimum. So you need to check. So you plug in this one 4 to here. So a prime prime 4 equals 2 plus 256 to the 4 to the negative 3 power. Right? Then what do you think? That's 2 plus 256, 4 to the cube. Right? Reciprocal. This one is bigger than 0. This is all positive. So it means what? It means the area, the material we use, the area is minimized when x is 4. Right? So here is 4 feet. If this is 4 feet, what is your y? Look at that, right? We have this. Y is what? 32 divided by 4 squared. So your x is 4, then your y is 32 divided by x squared from here, right? Then that would be what? 4 squared, 16, 32, 2. That means your height is what? 2. So what we are saying is you would design the box with what? Base, each side is what? 4 feet each side, right? And the height would be what? 2 feet. That would be your answer. Right? Got some ideas? Think over. Okay? So that would be these sections for the 2.7 and 2.9.